Hey there. Thanks for tuning in. Uh, the name of my talk is The Strategic Software Decision, and we're going to talk about when to code, train, or prompt AI system, which choice to pick when building your AI system. And let's see if I can get my slides going. So the goal is to enable technical leaders, business stakeholders, senior executives, and the goal is to aid them in their ability to systematically choose between traditional code, machine learning, and LLM approaches based on project requirements and constraints. The reason why this is important is because LLMs have sort of taken the world by storm, and there's a lot of questioning of whether, old methods of traditional software are going to be replaced by new methods of vibe coding or other techniques and methodologies that people come up with, and kind of where do all these new methodologies fit now that we have ChatGPT and things like that. So who am I and why the heck should you care? My name is Landon Gray. Below in the bottom left-hand corner is me giving a talk at RailsConf where I built a machine learning model to do some weather prediction in Ruby, which was sort of a novel thing at the time. I am an AI engineer at the CRM. I have over a decade in software experience. I've worked for and talked with many small, medium, and large-sized companies, both as a software engineer and as an AI engineer and consultant. I've spent half that decade, over a decade, in the industry working as a software engineer on the ground, building software. Did some freelance things as well throughout my career. And then I spent the other half in consulting, kind of talking with organizations, businesses about how, we could use software methodologies, and in the later part of my career, how to use AI in products. And then I would help sort of implement, build out strategies, did some project management, things like that. If none of that interests you, maybe you should care, because I've had many executives and technical leaders at top companies, even Fortune 500 companies. Some of those engineers kind of reach out to me and say, hey, seems like you know a little bit about AI and software and kind of where things are going. Could you check out my project and give me some feedback? I'm struggling with high latency in my application. Can you help me to lower the latency or adjust prompts? Or, there might be issues with evaluating the system, the AI system, and getting the right result. I've worked in building and standing up RAG evaluations for my current company to kind of help move things along. And I'm typically pretty well-rounded as an engineer. I've built out little small side projects and deployed things. So I kind of know a thing or two. So I want to start this talk out by kind of bringing up Andre Karpathy's talk that he gave recently at the AI Startup School. If you YouTube Andre Karpathy AI Startup School, he's the director of Tesla, that video will come up, and I definitely think you should watch it. It's a great watch. I'm going to highlight a section of that talk in this talk, kind of borrowing from his slides. So he posits that software is changing. We all know this. So that slide in the background says software in the era of AI. And he kind of goes through these three different stages of software. Software 1.0, software 2.0, and software 3.0. And he highlights those as software 1.0 being the traditional software development, writing code. Software 2.0 is more deep learning, so taking a bunch of samples and running them through a deep learning architecture and predicting some results. And then he talks about software 3.0, which has everything to do with transformers and large language models and kind of writing prompts to get results back from those models. So software 1.0, we write computer code and that programs the computer. Software 2.0, we have neural networks with weights, and we use those weights, we adjust those weights to program the neural network for some output. And then software 3.0 is we prompt engineer these LLMs to give us the results that we're expecting. And these two slides are directly from Andrej Karpathy's video and slides, but I just wanted to bring those here to kind of frame the rest of the conversation we'll be having. So some time ago, I was talking with a company in New York City doing about 100 million in what was this space? Sort of e-commerce space. And in that conversation, I had a technical lead ask me, when do you use AI, LLMs, and ML to solve a problem versus a traditional software approach? And I thought that was a great question. I kind of put a note in the back of my head, like, I got to write a blog post. I got to talk about this because this seems like something so obvious that I think, honestly, should be in every single company's, like, if you're hiring a developer, it should be an interview question. Probably every AI engineering role is, when do you want to use traditional software? When do you want to use more AI, LLMs, and things like that? Because I think sometimes engineers don't fully understand, and there's this misconception that we should just use AI for everything, and maybe we should use it in everything eventually, but I don't think it should be used for everything. That's my professional opinion. So my response to this tech lead was, and before I get to that, you don't even get to use LLMs, or I guess you get to use LLMs, but a prerequisite for 2.0 and 3.0 is having data. It's really good to have solid data for like building out deep learning models. But my response to this tech lead was determinism. That for me, I felt determinism was the line that I would draw in the sand as to whether I'm going to approach a problem in a traditional software way or using AI. And it's not always cut and dry. Like, it's not as easy as determinism. There are hybrid approaches. Like, sometimes it's both, or certain parts are need to be more deterministic, such as banking. You're doing a transaction. You don't want to get that wrong. You need to know what the system does for auditing purposes. But for purposes of, content creation or sentiment analysis, it can be a little bit more flexible generally. But determinism is sort of that line that I drew in the sand to kind of help guide when I would use LLM approaches versus traditional AI or traditional software, which is writing code. But then I started thinking a little bit more, and I'm like, is it just determinism? Are there other things as well? And so I kind of pulled in certainty and explainability because I felt like these were also important aspects of determining whether to use which coding methodology, whether it's software 1.0, software 3.0, software 2.0, which methodology to use. And I think all of them are still valid right now. I don't see any of them going away in the future, but I think we really need to understand when to apply each, and they all have different trade-offs. So let's talk about determinism and certainty first. So they may sound very similar, but determinism and certainty are not the same thing. So determinism is given some inputs, you'll always get the same outputs. You know what to expect. If I say 1 plus 1, the crowd says 2. If I say 10 minus 7, the crowd says 3. Like, every time, those will be true. Weird exceptions, you change the base to base 10 or something like that. So sometimes you get 1 plus 1 is 10 in base. Is it base 2? But yeah, you can look that up. But generally, if we're just talking about just simple math, 1 plus 1 is 2. It's not 10. So given some inputs, we know exactly what to expect. we have a level of certainty, which is confidence in the outcome, about what outcomes what will happen. We don't know for sure that every time, I throw the ball, the dog will retrieve it. But we're pretty confident that if I throw the ball and I watch the dog retrieve the ball, 7 times out of 8, I'm confident on the ninth term, and I have certainty that the dog is going to retrieve it again. There's exceptions, like the dog is tired. Maybe there's a pile of steak sitting by, or a meat truck driving by. Maybe there's a squirrel. That might throw off my confidence. But those are also things that we can predict and handle in this confidence certainty world. The last thing I want to talk a little bit about, and this came up when I was scoping some different projects that I was doing when I was running my consultancy full time, is explainability. This turns out to be very, very, very important. If you're a business executive, if you're a consultant working for a client, you'll know how important this is, because oftentimes you'll be asked by someone, by your board, by some stakeholder on the client, you'll be asked, like, how does it work? How do I know that something's not going to go wrong? And as engineers, we part of what we do is verification and explainability. If you're not doing that, you're not doing engineering. You might just be doing coding, but you're not really doing the work of engineering systems. Engineering involves explainability. We need the ability to understand and articulate how systems arrived at their decisions. And you may say, I think that LLMs have high explainability. They do not. In my view, they do not, because a lot of times people will try things like self-reflection, or they think these train of thought reasoning models have that sort of explainability. If I don't know how the LLM works, I'll just ask it to explain itself. And I think that's a decent, neat little trick heuristic. But I think when we're doing more harder problems, I don't think that flies. I think it flies when you're trying to do content generation, for example, and you ask it, explain how you came up with this thing. And it might tell you grammatically I wrote it this way. Say we're spell checking. It's explain how you knew how to, spell check. And it might tell you some flowery thing, but I don't believe it, because, as you can see in this definition, it's the ability to understand and articulate. I personally don't believe that LLMs have a notion of understanding. Their stoichiometric models, there's predictions and probabilities that arrive to correct conclusions, but that doesn't have the deeper level understanding and the rigor that many use cases need, in order to be able to even have, just passing stuff to the model be helpful in certain use cases. So we have to be aware of that. We have to be cautious of that, especially as we're unleashing these new technologies upon the world. And I'm speaking specifically about engineering. I know there are people who love to code, love to build little apps. That's great. But if we're talking about, serious use cases where we're dealing with users, healthcare, you name it, we really got to have some explainability. Okay, past that. So let's talk a little bit more about Andrej Karpathy's Software 1.0, Software 2.0, Software 3.0, and think about it in the lens of this determinism, the certainty, and the explainability. Now, I had ChatGPT kind of take a crack at kind of helping me put some of these ideas combined with Karpathy's thought leadership into specific slides. There may be some discrepancies on what you believe in the current state of how deterministic certain or explainable certain software patterns like Software 1.0 are, and you might find millions of edge cases where you say, Software 1.0, you say it's highly explainable, but what if you're calling some external system? Yeah, I know. You can't always know what some other third-party system's going to do, or a system from another team. We can write tests, we can do the best we can. Nothing's ever perfect, but this is sort of a best kind of approximation, and these slides are meant to be tools for you as an executive or technical leader, stakeholder, to kind of, you have a team that you're leading, you want to use AI technologies. Can you hold the problems and the use cases up to these slides to kind of help you think through a little bit better whether you're using the right approach in building software? That's what I want to kind of get at. So software 1.0, traditional code, writing code, folks coming out of boot camps, CS degrees, or being trained up through your organization to learn how to code. Software 1.0 has a high degree of determinism. It's kind of like the 1 + 1 is 2. You can code that and you can run that a million times and it will always be 2. And if it's not 2, your system crashed. So we have almost perfect determinism in certain use cases. We also have a high degree of certainty because we have a higher degree of determinism. Because we know what's going to happen, we can look at the code, we can audit the code. The times that we don't have the certainty is if there are segments of the code that we're less familiar with, then we may not know exactly what it does, but then you have to send some staff, senior engineer in there and kind of figure out what's going on. There be dragons. And then we have high explainability because we know exactly what it's going to do. So most of us know the use cases for this when you might need it. These heuristics are, we need deterministic outcomes, absolute certainty, complete explainability. Sometimes regulatory constraints, compliance lend well to this. We still know that you can still use AI in spaces where there's a lot of regulation, but there's a lot of sometimes hairiness that you have to deal with. So this is just like a consideration is like, hey, if I'm thinking regulatory constraints, maybe we should have more explainable code. Maybe we might want to code this part of our architecture in a more explainable way, so you can think about like hybrid approaches, like which parts do you want to offset to LLMs and AI and things like that, and safety, critical systems, and reliability. So in medical devices, aviation, a lot of these things, we're programming in these high performant, fault tolerant languages that we don't want to just have I don't know, like maybe Lua in a medical device where something could go funky. Not to pick at Lua, but like people might be doing C++ or different kind of lower level programming language, maybe working in assembly or something like that for some of these devices and things like that. So a couple examples here. You're all familiar with this, so I'm going to kind of skip this. Move forward. We can talk about software 2.0, which Karpathy talks about neural networks. So I asked Claude, and it was like, oh, it's technically determinism, but practically it's like maybe less determinism. We don't always know. You're not always guaranteed for like the neural network that it's always going to like classify a thing a certain way. There is some stochastic like randomness that sometimes involved, which also affects certainty. We have degrees of certainty, but we have degrees of certainty on the neural nets on the data that we train. So if the data is in the same vein or form of or similar to the data, like our training and testing set, and we've done some verification and we have a 90 or 80% confidence, if you find data like that, it's going to have that level of certainty. But if things change, and so sometimes you'll have newer data sets that are getting produced that may not produce that same level of certainty. So you have to retrain your model and all that stuff. So data is like a really, really big part about keeping that certainty and that level of determinism where it needs to be. One of the struggles with neural networks, and this is like changing, like there's been a lot of research, and I don't really follow up on the research, but I know I've seen work and papers and things like that being done where they're trying to work on the explainability problem, but it's still a little bit difficult, to kind of, if a business stakeholder comes to you and says, hey, what is it doing? You kind of have to be like, okay, like let's kind of squint and it's hard to give like a one-word explanation about like how does the system work, versus I can typically do that pretty well in software, and it's easy to tweak. It's not so much with neural networks. You have to you want to tweak it, you got to retrain a bunch of stuff, so there's some slowness there. But here we'll see if we have pattern complexity, If we have certain patterns, we can use neural networks to kind of learn the rules of games. We've seen that in chess. If we have abundant training data, that might be an area where we can maybe leverage this tool. If we have a tolerance for uncertainty, if sometimes it's acceptable that we don't get the outcomes that we need, but most of the time we can get the right outcomes and still make money and not kill anyone. It might be acceptable. And as you know, like they're testing Waymos in California right now, and Tesla's got the self-driving cars. So they have a much higher levels of certainty there, but they have to test a lot, and they haven't been able to roll it out in the whole U.S., like just these specific areas. So like to kind of cut down on that certainty of kind of domain, what's going to happen when it's in New York and doing things there. Like we don't have Waymos in upstate New York, partially due to this uncertainty. Performance priority and confidence thresholds. So things like image recognition, fraud detection, cancer detection, things like that. So this will be a lot of ML engineers working on this. And then software 3.0, we have a kind of low determinism. You can debate on these like low, medium, depending on like the domain. It can be very different. I'm sure in some use cases you can get high determinism. And typically I would say like low to medium certainty. A lot of times there's a lot of like uncertainty around cyber like security issues where people are doing like prompt injection attacks and doing all these like funky things to make the LLMs perform in ways that they were unintended. So a lot of uncertainty there, or just the user doing certain things that like aren't quite expected, and a lot of times the language models can have some issues, and that can affect your product. So being aware of that, and then the model, I don't know. Sorry, I forgot to change the slide. It says high explainability, and I already explained before, and I apparently forgot to take it out of this slide. I don't really believe it has high explainability. I don't really trust the model self-reflecting and telling you kind of what it did. So I think this is like a use case of that, where the model kind of generated this slide and was kind of like, reasoning, it can think, it can process. Like I don't necessarily believe that. So like there'd be dragons. But and I'll update this slide before I put this one out. But but yeah, so it can seem to explain stuff to you. If there's like reasoning transparency, so you can kind of get that feel of like, oh, like for a user, it might be sufficient that the LLM explains something to them and make them feel confident. Maybe that's like a pattern in which you can need this. So you have some flexibility, determinism, reasoning patterns, variable output. The big thing for me is like the natural language explainability. So it's able to kind of put difficult concepts into like break it down in ways that humans can understand, and kind of take disparate data and kind of break it down and kind of highlight what's important. I think that's super important. And then iterative refinement, you can adjust the behavior through conversational feedback. I really like that. You can talk with LLMs and kind of adapt the user experience, versus with software 1.0, it's a little bit harder. And I'm going to update the slides a little bit, just to kind of fit this when I put it out. But we've already seen how LLMs and prompts can be used. We've seen AI assistants, we've seen AI code generation, analysis tools, creative writing, and customer support bots and things like that. So it's very, very useful. But there's a lot of gaps and holes. I think moving toward more hybrid approaches, where kind of leaning on traditional software systems for the things that we know, like user login and things like that, pretty set patterns. We know how to like deploy software and things like that. Not so much trying to lean on LLMs for that. If you're trying to use it to deploy software, build out like Docker containers or systems, it might hallucinate and maybe pull incorrect packages and versions of things. So that's like a challenge of like the code generation stuff, versus like if I was going to build a tool to build a PHP environment, I might lean on software 1.0 to kind of like script out the initial stages of like setting up the environment, pulling on the dependencies, and I might lean on software 3.0 to kind of make changes to the software. And so that would give me a stronger code assistant than just if I just had it like pull just whatever versions were in the model, like the model was trained on. I can get the newest versions of the software and update those more systematically. So something to think about there. And then I had sort of like this secret slide. It was a question for Andre Karpathy that I ended up asking on X as well. And I kind of was like, what happened to like the traditional ML? And I felt like that was a missing slide. I actually don't believe these medium certainty things. I think there's a lot more variance here in terms of which ML models you're using. But I still think there's a place for, different classification models, random forest, linear regressions, support vector machines. Like I still think there is a need for these, and many of these, because they have a little bit, higher explainability, maybe higher certainty than LLMs and more determinism than LLMs. Because of that, you'll see them these things can be kind of used for, cancer detection and things like that. I think these are probably used more than maybe some LLMs and things like that. That lends into being really good for regulatory requirements, explainability. You have moderate data needs. I don't know why I'm working backwards. Moderate data needs. So you don't need as much data as you would if you're trying to train a deep learning model. So that might be a stopgap between deep learning versus you don't want to program something out. You have a little bit of data. Maybe traditional ML 1.5 would be good for you. And here's a couple more examples. Oops. I'll click on here. And yeah, that's all I had. So this, if you found this to be helpful, or if you have questions or clarifications, or even if you have criticisms, I totally want to hear it. You can email me at landongray@hey.com. I also have a newsletter, buttondown.com/landon.gray. I haven't been publishing there as much, but it's a good place to kind of follow because occasionally I'll have blog posts that I'll probably put in there, and you can kind of find out things that I'm up to, or if some of my blog posts might end up there as well. And then if you would like to, you can connect with me on LinkedIn.com. Just want to say thank you. If you're watching this on YouTube, if I put it on YouTube, you can feel free to follow, like, subscribe, like this if it's a post on LinkedIn, wherever you see it. I really appreciate the time. And yeah, reach out and have a great day.